In this video, we're going to discuss the conditional statement in the bash shell interpreter. So we're going to apply that obviously to scripting. So this is going to be the first time we can sort of control the flow of execution of our script, so that's going to come in very handy. But before we get into the if statement, syntax, and all those things, I want to start with a little reminder about error codes. So every time you run a command, for example, ls of my current working directory, or maybe ls of a folder that most likely does not exist, okay? All right, so every time I run a command like that on the shell, there is an error code that is returned to me. The error code, by convention, is 0 if everything went fine. So if the command executed successfully, for example, ls of an existing directory like data2, for example, in my current working directory, well then the return code should be 0. So it might be a little counterintuitive because in other programming language 0 is sometimes interpreted as false, and here it's interpreted as a success, and we're going to see in a few minutes that success in bash means true, okay? So a little trick for you to remember this, think about, if that helps, 0 is okay, and spell it with a 0 and a K. Okay, that's going to help you remember that 0 means everything went okay, and this is going to be our definition of true, the Boolean value true in the bash shell. So how do we get access to those codes? There is a special shell variable that we can use, and it's spelled with a dollar, like any shell variable that we want to access the content of, and then question mark. So if I do echo dollar question mark here, it's going to tell me 0. So what this special variable means is what is the return error code from the last command I executed. So in my shell I executed here ls data2, okay, this is the output of this successful command. I try to display now the error code that was returned to the shell by the command ls, and it tells me, well, the last command you executed returned 0, which means it went okay. So let's try something like we did before, like ls of a folder that doesn't exist. So now I execute this command, it displays an error message that says, I cannot access this folder, and if I try to display echo dollar question mark, here's what I get. I get something different than 0. So something different than 0, whether it's positive, negative, whatever the number is, always mean there was a problem. And the specific value can be, for example, here 1, 2, 3, etc. That specific value is going to be documented in the command, in the program that you just executed, and the documentation will tell you exactly what the specific error code means. So here we can guess that since ls was not able to access, this folder that doesn't exist, well, the error code 2 must mean something like, well, I was not able to access at least, one of the files or folder that you specified as argument. Okay? So again, to clarify, 0 is okay, all right? And anything but 0 is going to be an error. And another way to remember that there is to remember this convention is to think that there is only one way for the command to work out. Okay, if it works out, it just works out, so 0 is fine. And then there may be different reasons for which a command failed. So we need several numbers, several different error codes to be able to communicate back to the shell exactly what happened. Okay, so that's another way for you to remember easily. 0 is okay, and then anything else, a bunch of different numbers might mean a bunch of different error conditions. So now that we have this out of the way, okay, we have a definition of success and failure in terms of bash shell. Okay, that's the error code returned by a command. And then we have a way to access that error code. Well, let's just add a little bit of syntax and try to leverage that in our script. So if I go inside a script and I do something like that, ls/var, and a bunch of characters here, a directory that doesn't exist, okay, I can, of course, display and access this special value here. Okay, I can say something like the ls command, I cannot type today, I just ran returned error code and there we go. Okay, so I'm going to save this. I'm going to save this in a file named myscript.sh. Let's try to execute my script. So it executes the ls, okay, nothing new here. And then it executes that echo statement that is using actually the $? To tell me pretty much what happened. Okay, but now what I would like to do is I would like to display a message that is something nice if the command worked, and display another message if the command didn't work. Okay, so I'm going to keep that echo for now, but then I'm going to use our first if statement. So the syntax of the if statement in bash is if, then potentially an optional else, and then the way to close the if statement is a little weird. You type fi. Okay, so fi is the opposite of if. Okay, so that's another thing to remember. So here in front of the if line, you are going to have your condition. Okay, so we're going to come back into that in a few seconds. But then after the then statement, you go to the next line, you indent, and you say, for example, echo everything worked fine. And the else statement would be indent echo, oops, there was a problem. Okay, so now what is this condition here? So we are going to learn to write a condition with if statement, but right now we know that the error code of a command is going to be something that we can interpret as true or false. True is success, false is failure for whatever reason. So what we are going to do first is we are going to remove that echo command. We're going to cut that statement here and put it there. And this is the first thing to understand about the if statement in bash. Okay, the if statement is meant to run a command, and then based on its error code, based on the error code it returns, okay, determine whether that error code is to be interpreted as true, so a success, and then execute some code, or if it's to be interpreted as false, a failure, and then execute some different code. Okay, so I save that file. Let's try to execute it. This is what we get. So we still get the display of the ls command. So the ls command was actually executed. Okay, no mystery there, nothing different. This ls command was not able to find the folder that I specified here. So not only it displayed an error message, but it returned an error code that we saw previously was equal to the integer 2, and that meant, you know, well, something went wrong. I was not able to find the file. So because that error code was different than 0, guess what? It was considered to be false. So we executed the part of the if statement that is in the else branch. Okay? If I was trying to list something that exists, so I use the example of data2 previously. Okay, so this is actually a folder, a subfolder in my home directory. So let me save the script. So this time it should work. Okay, I'm executing the script again. So yes, the ls command executes, the ls command works, and then it returns its error code, and its error code is 0, which means it's interpreted as true, which means we execute the then part of the if statement. Okay, so to wrap this up, we talked about the if syntax like this. Okay, we can remove that else statement. Okay, I'm going to save. I already mentioned that this was actually this was optional, and I'm going to do something here to speed up things a little bit. I'm going to say, hey, let's do an ls of the first argument that was passed. Okay, so that I can call my script with, for example, this folder, and you can see it worked. Okay, so perfectly fine. And then if I call it with /var/blah blah blah folder that doesn't work, you can see that, okay, because this was false and there was no else counterpart, I didn't do anything, right? So that's exactly the behavior that we intended to have. There is another interesting thing with the if syntax. So we can have else statement. I'm going to put it back. Okay. We can also have something else called the elif statement. So the elif statement is, as you might have guessed, else if that has been condensed together. So you can write, you know, elif, okay, so else if, And you can put here another condition. So I could say, for example, all right, so if, let me try to find an example that would fit here. So if this folder or this file name doesn't exist, I'm going to try to do ls of my second argument. Why not? Okay, and then I have a then part here. Okay, so I can say, well, I was able to, to find, I was able to find the second argument. So that should become something like, I was able to find the first argument. We need to make this a little shorter. Okay, so I found the first argument so that it fits on the line. I found the second argument. Okay, and if I cannot find the first and second argument, then there is a problem. But you see how you can write this cascading series of if-else statement without having your indentation go completely crazy and push you all the way to the right of your text editor. Okay, you simply say, okay, I test this condition. If it's true, I execute this. Then if it's false, then I test this new condition. If it's true, I execute this. And if it's false, if both of them were false, I end up right here. Okay, so let's save. Let's play a little bit with the script. So I'm going to say, here's my script, and I want to access ls of data2. And then my second argument will be something that doesn't exist. So the first argument, the ls executes. All right, execute successfully. So return error code is 0, which means true. The then part of the first if is executed. Now, if instead of data2 I specify first something that doesn't exist, and then something that exists in my current working directory, okay, here's what's going to happen. I execute the ls on the folder that doesn't exist, /var / whatever, okay. Return error code 2, we saw that previously, so this is false, so I jump here. Now I try to do a ls of my second argument, which was the name of a folder that exists. Error code return is 0, which is true, therefore I display this message, okay. And then the last case, the last possible case, we are going to provide another folder that doesn't exist, okay. Alright, so two var folder that are actually not there. So I execute this. First ls executes here, fails, okay, so the return code that tells me it's false and it displays an error message. So I execute the second ls, or the second argument, it fails also. The return error code tells me false pretty much. So I end up here in that else statement at the end that tells me, oops, there was a problem, okay. Last thing, we might as well discuss it here. There is a somewhat abbreviated syntax that you are going to encounter in other programming language like Perl and Ruby. The syntax makes use of the double ampersand operator and the double pipe operator. So you've seen those operators elsewhere. Okay, these are commonly used to represent the logical AND operator and the logical OR operator in a wide variety of programming languages. Okay, in the context of the shell, yes, they can definitely be used to that end. Okay, no problem. But there is a sort of idiomatic usage also that is when you want to execute a command, for example, ls data2. Okay, so you want to execute a first command, and only if that command succeeds, you want to do something else. So you want to chain a bunch of commands, but it's always the previous command needs to succeed so that you go to the next and execute it. And if that one succeeds, you go to the next and execute it, and so on and so forth. So the double ampersand, the logical AND symbol, is used to do that. So I could say, for example, let's do a ls on data2, ampersand echo this worked. So if I run this, okay, there we go. The result of the ls, okay. And then the return code from the ls is 0, meaning success, meaning true. So here's what happens. The double ampersand operator is a logical AND operator, and the bash, like many programming language, is going to have a sort of lazy evaluation of conditions that have multiple terms separated by logical operators. So in the case of the AND logical operator, You know from what you learned in programming about truth table that the only way a proposition with an and two terms around it, the only way it's going to be true is if both of them are true. So when the first part of the command here returns true, I still need to execute and evaluate the outcome of the second part of the expression in order to determine if the overall expression is true or false. This is why when the ls is successful, then the shell looks at the over command, executes it, takes its return value, its error code, and then combines the two error code to return true or false. So this echo could fail or succeed, okay? It doesn't matter. It has to be evaluated for us to make a decision on the overall true value of this Boolean expression. However, if if the first term here corresponds to a folder that doesn't exist, data queue, for example, then here's what's going to happen. This first command, ls./dataqueue, is going to fail. Return an error code different than 0, which is interpreted as the Boolean value false by the shell. And now we have a AND logical operator. Well, one thing that the shell knows already is that if the first term of a Boolean expression with an AND operator is false, well, no matter what is the true value of the second term, that's not going to change the outcome. The overall expression is false. False and anything, whether it's true or false, always results in false. So therefore, there is this little shortcut, this little lazy evaluation that kicks in, and the shell is not even going to bother trying to figure out if the second term of this Boolean expression is true or false. So in concrete terms, in very pragmatic terms, that means that Bash is not going to even try to evaluate this echo statement, which means it's not going to execute that command at all, okay, because the first one was false. So this is what gave birth, to this idiomatic approach, which is if I want to execute, for example, ls data2, and only if it works, I want to then find the correct symbol, there we go, and then I want to do something like ls /data1, and only if it worked, if that second one worked, I want to say, well, echo both commands worked. So I have this little syntax, completely idiomatic. You'll find it in Perl, you'll find it in Ruby, you'll find it in Bash, okay, that allows me to chain those commands and make sure that the next one in the chain gets executed only if the one right before it succeeded. And as soon as one of them fails, okay, for example, if I make this one here fail, you're going to see that we stop executing the chain, okay? There we go, one error message, and then the second ls never got executed, so the echo statement never got executed. And if this one is the one that fails, as you guessed by now probably, as the first one works, so I go to the next one, I do ls./dataqueue, it doesn't work, error message, and then I stop. I don't even go to echo. So the same way that we have, this AND logical operator, we have a OR logical operator. Okay, so the logic is the same, but it's kind of the opposite way, all right? So if I do something like ls data2, okay, and I say or echo something. So the logic of the OR operator is opposite of the AND operator, meaning that if the first term here is true, okay, I don't need to go any further. I know that if my logical proposition is x or y, as soon as I determine that x is true, no matter whether y is false or true, the overall expression is going to result in true. Again, I refer you to what you learn about truth tables, either in discrete math or when you were taking your programming courses. So in this case, there's still laziness in the evaluation. Bash is going to say, well, if the first command works, okay, I don't need to execute the second. If the first command fails, so result into a true value that is false, okay, well then the true value of the overall Boolean expression is going to be either true or false, and that's going to depend completely on how the second command executes. So I will, meaning the bash shell, I will execute the second command, okay, and try to figure out what is its return code, and then try to figure out if that return code is true, means true or false, and then combine this to the false that I got from the first command, and return overall true value. Okay, so let's execute this. There we go. The first one didn't work, so if this command doesn't work, then I go and I do echo something, and you can see the display. So those are two things that you're going to encounter in a bunch of different programming language, certainly in Shell. So I wanted to introduce them early so that you see how the if syntax can be represented in different form, and how we can use it practically in Shell scripts.